In this session, guys, we're going to be covering multiplying index expressions. Let's get it started. Now, you might remember just the letter x by itself. Now, this is the same thing as saying 1 times x, or x to the power of 1, or it could also be written as 1 times x to the power of 1, or just another way of writing this. Now, all these four things, they're the same thing. 1 times x is x. X to the power of 1 is x. 1 times x to the power of 1, it's still x. 1x to the power of 1 is also x. But we just like to write x by itself. So, the next thing is, if you remember, probably before this, the last few years we might have done this, you write 2 squared is equal to 2 times 2, which equals to 4. You also did something like 3 to the power of 4 could be written as 3 times 3 times 3 times 3, which equals to 81. Likewise, it's no different if you have x to the power of 4. Because if you have x to the power of 4, this could be written as x multiplied by x multiplied by x multiplied by another x. It's just another short form of writing it. We just write it x to the power of 4. In some places you might actually see this happen. Like they would write, for example, if I have a to the power of 3, they'll also write it as a dot a dot a. In other words, this is the same thing as saying a times a times a. So the multiplication sign is the little dot right there. Okay, now that we have got that out of the way, let's actually try and do some problems here. So, if you have a to the power of 4 multiplied by a to the power of 2, let's see what happens if we expand this out. So first off, a to the power of 4 is going to be a times a times a times a. And if you had forgotten that, that is your a to the power of 4. Then you have your times, which is this thing right there. And then we have a squared, which is a times a. That's that lot right there. I'm just going to color it just to see that you guys can see it. A to the power of 4, there's 1, 2, 3, 4. Now, if you actually count the number of a's, you are going to get a to the power of 6. Or in other words, a to the power of 4 times a squared is a to the power of 6. Now you might ask this question, well, do I need to do this every single time? Well, actually you don't. I mean, if you can see a pattern, in the next question I'll give you some time to think about it and see whether you get the pattern. Alright, so what about something like this? If we have x to the power of 7 multiplied by x to the power of 5, what's this going to equal? Well, the thing is, as the numbers get bigger, you don't really want to write down all the number of x's and all the number of, and then multiplying and adding x's. What you really want to be doing is when you multiply the two powers, they get added. So in this case, the answer is going to be x to the power of 12. Let's try another problem. If I have something like y to the power of 6 dot y to the power of 3, remember that times is the same thing as multiplying. So in this case, it'll be y to the power of 9. So just doing a few more quick examples. So if you have a to the power of 10 multiplied by a to the power of 2 multiplied by a to the power of 3, then this is a to the power of 15. So We just count the number of a's that we actually are multiplying together by. Next thing, what if we have something like this? Y to the power of 7 times y to the power of 6 times y to the power of 1 times y to the power of 2. Once again, just look at how many y's there are. You've got 7 plus 6 plus 1 plus 2. So that's 7 plus 6 plus 1 plus 2 equals 15. So in this case, it's y to the power of 15. Okay, moving on to the next idea. What happens when you have something like this? If you have x to the power of 7 times x, what's that going to equal? Remember the dot? It's just another short form of writing multiply, so you don't get confused with the x's. And also remember back to the first thing that we learned in this session. X can just be written as x to the power of 1, which means your answer in this case, it's going to be x to the power of 8. Okay, hope you're getting this. We're going to go a little bit more complicated. We're going to start introducing two variables now. So for example, what if we have x squared y cubed multiplied by x cubed y to the power of 4? Nothing changes. I mean, if we expand this into big things, we're just still going to get something like x times y times y times y times y times x times x times x. As you can see, this is just getting messy. You know what? I'm just going to rub this all out. Let's just go back. This is just taking too long. This can be written as, also, because they're all just being multiplied, you could just do x squared times x cubed times y cubed times y to the power of 4. And then, your next lot is, you're going to have x to the power of 5 and y to the power of 7. So if you guessed that answer initially, you're correct. So the whole point, guys, is to try and collect the x's and the y's. You don't want to be expanding it out, because if you write it in the full format, it's going to take you a very, very long time. So let's do another example here. What if you have something like x to the power of 7, let's do y to the power of 5, z to the power of 3 times x to the power of 2, y to the power of 2, and z to the power of 2. Well, this is simple. You look at how many x's have you got there. X to the power of 7 times x squared is x to the power of 9. Then y will become 7, and z will become 5. Okay. Got a few more ideas to cover, and then we're done with this. What do we've got? Okay, now this is something that you would have done before. If you remember, you would have done 5 times 6x equals 30x. So just because, I mean, what if we do something like this? 5 multiplied by 6x squared. See, the thing is, the numbers, you're still going to be multiplying. Where is my different color? Let's go with that. When you multiply the two numbers, you are still going to get 30. And the x squared, well, x squared is just going to be left behind. Because remember, 5 times 6 is 30, and the variable x, we can't really do anything with it. So you just leave it as it is. Okay, so to the next one. What if we start having something like 5a to the power of 2 multiplied by 4a to the power of 3? Well, the first things are obvious. We're going to try and multiply the numbers first. So when we do that, we're going to get 5 times 4, well, that's 20. And then we've got a squared, a cubed. Now, if you're fast enough, you can all do this in one big line, but for now, I'm just explaining to you guys that this would be 20a to the power of 5. And that's your answer. Okay. How about we change the number now? What if we have something like 6x times negative 2x to the power of 4? So remember, the first thing it says, do your numbers first. 6 times minus 2, well, that's negative 12. Then you've got x and x4. Now, notice I'm just going to put a little dot there because that's the same as multiplication. Also, remember that if x by itself, then it's to the power of 1, which means this answer is going to be negative 12 x to the power of 5. Okay. 2 more problems and then we're finished with the session. We got, what about 4x to the power of 8 multiplied by 6x squared? Okay, once again, collect the numbers. 6 times 4, that's going to be 24, x to the power of 8, and then x to the power of 2. And you can get straight away 24, x to the power of, what is it? 10. Okay, let's do our last example, and after this you should really have got multiplying index expressions. Well, let's see. So I'm going to give this problem here. 9x cubed multiplied, actually let's start using the dot, multiplied by 7y cubed multiplied by x cubed and y to the power of 5. So let's start doing the numbers first. You've got 9 here, and then you've got 7. Now here, you've got no number here. But remember that if x is by itself, then it's the same thing as saying 1. So I'm just going to write on the side here, 9 times 7 times 1 is going to be 63. So the answer is going to be, let's write it in a yellow for you guys, 63. And then let's write down the x's. Well, you've got x cubed and x cubed, which is going to be x to the power of 6. And then you've got y cubed and y to the power of 5, which means that's going to be y to the power of 8. So your final answer is going to be 63, x to the power of 6, and y to the power of 8. I think that's enough for this session. Okay, see you.